Good afternoon. How's it going with everyone?
Good afternoon.
You hanging in there?
Yeah.
Yeah. Oh, that wasn't very confident there, Elena.
Just tired.
Yeah, it's the way of the world, I think, right? Yeah, me too. All right. So I'm just getting ready to publish next week for you. I know you're like, what are you talking about? I'm still in this week. But I'm just getting ready to publish that for you guys. And I don't want you to freak out when you see it. It looks like there's a lot of assignments, but several of them are optional and some we will do in class. So it's not as bad as it looks. I promise. Your cat looks so happy, Elena.
Oh, she's just napping.
Yeah.
She's awake now. She's
All
just
right.
cleaning.
I'm going to turn off my video for just a minute. My dog is having some kind of attack crying. So yeah, I'm going to go to check on him and I'll be right back. Hello, hello. How's everybody doing? All right. So I was just telling them that I'm almost ready to open up next week. So you can get a jump start on that. I know some of you are like, what are you talking about? I'm still on this week, man. Like, back off. It's okay. You don't have to look at it, right? Till you're ready. I'm just trying to get it out there for you in case you're ready. And don't be overwhelmed when you see it. There's some optional activities and there's some stuff we're going to do in class. And some of them are not very long, but they're separate. So I'm almost ready to do that. But I have office hours at 2 today. Don't forget, right? If you need them, because I moved them from this morning. And then we have our last Educator Rising meeting today. It's our party. Is anybody coming? It's at a different time. It's at, let me look. We've changed the time like 17 times, so that's why I'm not positive what time it's at. I'm sure it's on my calendar. It is. Why isn't the time right there? Hold on. Goodness, does anybody know what time it's at? I know I put it in my newsletter. It's probably wrong in my newsletter now because they changed the time, but let me look. Calendar, there's my calendar. Wow. Okay, it's at 6:30, from 6:30 to 7:30 p.m. tonight. The Educator Rising meeting, if you are interested in it. So, and we're just playing games and having fun. That's it. All right. So, did you get my email this morning? I think I sent you one this morning. Wow. Yeah, it's quite a week, quite a day, quite a everything. Hopefully you won't hear my stomach growl today. Ha, ha. That was funny. I have forgotten about it. No, I haven't. I have not forgotten about it. All right. So thanks, Vanessa. That's fine. So Ed Rising meeting tonight. (6:30 to 7:30). Okay. So, what else do we have going on? Let me share my screen. We're going to do interior and exterior angles with polygons today. These are our objectives. Let's talk Thunderbird Thursday. There's an opportunity available to you that you may be interested in. I know you're like, I cannot do another thing right now. I get it. But the reason I'm bringing it up is because you don't have to do it. It says it's available through June 23rd. So I was like, okay, get through 2 weeks. Maybe you want to do it. Maybe you don't. I don't know. But it's free for MCC students, and it's resilience training, resilience by leadership. And you're supposed to watch this video before you go if you want. So I can put that video in the chat. It will be a link once I think these slides are already up. So should be already there.
Are you trying to share your screen? Because we don't see anything.
Pickles, pickles, pickles. Hold on. Yes, I was sharing my screen, but I wasn't. Can you see it now?
Yeah, we can
All
see
right, good. So resilience training. Does anyone know what the definition of resilience is? Do you know what it means? Any idea what it means? Ah, okay. So it's kind of like persistence or perseverance, right? But it's a little more because it's resilience means that you can recover quickly from a difficult situation. Sometimes people say, oh, you're tough, right? Because something bad happened and you recovered pretty quickly. So that's what resilience is. And boy, as a teacher, you're going to need some resiliency. Yeah. So if you're interested in that, check out the slides because you can watch that 25-minute video. Maybe you watch the 25-minute video and you're like, that's enough for me. Goodbye. Or maybe you go, oh, this is fascinating. I do want to continue this course. And it shows you how to do it, like on this flyer over here. You create a profile on resilience.leadership.org. Okay. All right. So let's just talk for a minute because we didn't go through the developing area formulas. And I know that some of you have turned it in, which is fine. Some of you have not. But, oh, that link's not live. Hold on one moment. It's live in here. Did anyone start the assignment and then go, I'm confused? All right, Jessica did, Kelsey did, Elena did. Okay, so let's take a look at that. I'm gonna put this link in the chat. Oh, wrong button, wrong button. Sorry. I'm having quite a day. I made an 8-minute video this morning and it didn't record. It recorded like it was recording because I checked it. And then it stopped about halfway through and I didn't notice. Yeah, super fun. So now I get to make it again, but I started making it again and I only made half of it because I was like, I'm going to save it in case it screws up again. So, because it was like a long video, like 8 minutes. My videos are not usually that long, usually like 3 minutes. Okay, so I just put it in the chat basically for me to pull, but if you wanted to pull it, you could. So developing area formulas. And I have links in here. So there's a handout for the activity. And the handout, hey, maybe I put it in my OneNote. I bet I did. So developing area formulas. So the slides tell you you can pull this handout if you want. And the slides also tell you that you can, let me get back to them. The slides tell you you can use dot paper and it has a link to the dot paper, or you can see graph papers here, dot papers here. Okay, so you have access to all of those to do this activity. Then what you want to do is, we'll just follow the instructions on this paper because I think it might be a little more simple. So draw a parallelogram, label it A, B, C, D, then cut out the parallelogram. So draw it on your dot paper or draw it here, cut it out. It says draw the height of a parallelogram to vertex D, then cut off the triangle and move it across to the other side. So you're going to do that all on your dot paper and you're going to get a new figure. Well, if you look, I'm just going to draw it because I don't have my scissors or anything right now. So if this was the original shape, this is D, this is C. On my new figure, that was my original figure. My new figure is going to have this moved right over here. So this is my new figure. So it says cut off the triangle, move it to obtain a new figure. What's the new figure I created? So what is this new shape that I just made? Thank you. Rectangle. It's a rectangle. Now, how does the area of the original figure, which was a parallelogram, and the new figure compare? Is one bigger than another? Are they the same? What's happening with the areas? Anyone? Yeah, the area is exactly the same, right? Because all I did was take off this little piece and I moved it right here. So I haven't changed my area, I just moved it, right? So the area is the same. So if you know the formula for a rectangle, area is length times width, and you could write out length times width, or if you go with base times height, it's up to you. So if here's the rectangle, length and the width. Now, if you look at a parallelogram, you're developing this formula. So a parallelogram, okay, our length is now the base of the parallelogram, and our width, which was here, is our height. So that's where the formula for a parallelogram comes from. Okay, it's base times height. We can't say length times width. Yeah, so then after that one, you're going to go to the next one. It says cut out any triangle you want. Cut it out. So draw it on dot paper or graph paper cut it out. Cut out an identical copy of your triangle. Rotate them and fit them together. What's the new shape? You might be like, okay, and then how does the area compare? And then create a formula. I don't want you to just write down the formula. I want you to explain to me where that formula came from because you just figured it out. Yeah? So this isn't, do I know the formula for the area of a triangle? Because you can look that up anywhere. It's where did this formula come from? Yeah? Then you're going to do the same thing with trapezoids. Now, when you rotate it 180 degrees, your new trapezoid should go over here. And I'm going to show you that by going to something else. I'm going to go to this. So let's look at this one. If you click that, why is that not live? Hold on. All right, so in this one, okay, I'm putting a link in the chat for this GeoGebra. So if you go to this GeoGebra link, this is what we just did, low tech. Yeah, so there's the high tech version, so you can see it. So when you're stuck on the trapezoid one, click that link at the bottom because it'll show you what you're supposed to be doing. Yeah? So does that help, Jessica, Kelsey, Elena, those of you that were stuck?
Were we supposed to do the in-class portion where we like find 3 objects at home?
So down there, it's up to you. I mean, I think it's a great idea to do it, but do you see, I have one filled in for you. So I have an everyday measured objects and I have all those numbers in there for you. So you don't have to do that part, but if it was me, I would, right? Because otherwise I'm not sure you really understand what's happening, but it's up to you. Okay, any other questions about the developing area formulas? You all right? Okay, don't forget to put your responses up on your OINC discussion board. Some of you are forgetting because you post on Wednesday and you posted early and nobody else posted and you're like, what the heck? And remember, post on someone who you didn't have the same numbers as them. Okay, so now let's go back to today. We don't have to review our polygon names. We already know them, but a circle's not one. We should review what's an interior angle and what's an exterior angle. So an interior angle is an angle inside the shape like this. So the interior angle of this hexagon is 120 degrees, whereas the exterior angle is if I drew a line extending from the vertex, then it's that, okay? So I think that's okay, interior angles versus exterior angles, because you have to be careful and not confuse the formulas. What's the diagonal of a polygon? Anyone know what a diagonal of a polygon would be if you were going to describe it?
Isn't it between 2 vertexes on the inside?
Yeah, so if you go from one vertex or you go all the way across, right? You go all the way across. So on a triangle won't have a diagonal, right? Because if you go from one vertex to another, it's just the side of the triangle, right? So if we draw it like this, oops, if we drew a triangle, if I want to go from one vertex to another vertex, I'm just going to end up on the edge or the side of the triangle. But if I do a quadrilateral and I go from this vertex to this vertex, that's a diagonal. Okay? So just a reminder of that. Okay. I had a worksheet for you for today. I don't know, there it is. I'm going to put it in the chat right now. If you already have it printed, that's totally fine. Okay. So this says use triangular pattern blocks to create a hexagon, sketch your figure. What type of triangle is used to create the hexagon? What's the sum of the interior angle measures in each triangle? So if you were going to put those pattern blocks together, that's what those pattern blocks would look like, right? Remember those little green triangles? If we put those all together, they would make a hexagon. And those little triangles are equilateral triangles, right? They were like the perfect triangle, right? A regular triangle. So we know that all of those angle measures are the same. So since the 6 triangles form a hexagon, I know that the total angle measures is 6 times 180. So, right, because the interior angles of this triangle, let's say right here, this triangle, is 180 if I measure all 3 angles, right? Well, I have 6 of those. So if I multiply 6 times 180, I will get 1080 degrees. But there's a problem. I've included these angles that aren't really interior angles of the hexagon. They're parts of the triangle, but they're not parts of the hexagon because the angles I'm really looking for are just these angles. So a solution would be, oh, all of these, if I go all the way around this, I end up with a circle. And I know a circle measures 360 degrees. So if that's the part I want to get rid of, I can take that 1080 degrees, subtract off the 360, and I'll end up with the sum of the interior angles of a hexagon must be 720 degrees. Nice? Did anyone memorize the measures of the interior angles of any polygons before, like when they were in high school? Yeah, so I could never memorize them. I just kept forgetting them over and over and over again. So this is going to be a strategy of how you can figure it out in case you forget when you're taking the test or if you're in front of your classroom or whatever. So Ryota thinks he can find the sum of the measures of the interior angles of the hexagon in problem 1 without using a protractor. So if you look at this document right here, so he has now, he wants to see if it works for other polygons. So this is a pentagon. And what he did was he decomposed it into triangles. Basically, he put a dot in the middle, right? And then he drew these lines. And he doesn't have perfect triangles, right? He doesn't have equilateral triangles, but he still decomposed the shape into 5 triangles. Everybody sees those 5 triangles, right? So can he use this method still, even though he didn't make equilateral triangles? What do you think? What is the sum of the measures of any triangle? The measures of the interior angles of any triangle? $180 degrees, absolutely. And so it doesn't matter what the triangle looks like, right? Each one of these triangles, all 3 of the angles, right? This angle, and this angle must sum to 180 degrees. And that's true for every single one of these triangles, right? Do you agree? Yeah. So now that's the first part. So how many triangles do I have? 1, 2, 3, 4, 5. So I have 5 triangles. Each triangle measures 180 degrees. So 5 times 180 is what? 900. So 900 degrees is the total degrees, but there's a problem because that includes these angles. And I don't want to include those angles, right? Because those are not interior angles of the pentagon. They are just part of the angles from the triangle that I used. So all these angles together must sum to what? 360 degrees, absolutely, Betty, because it still goes all the way around in a circle with all of those angles. So if I take that 900 degrees and subtract off 360 degrees, that must be the sum of the interior angles of a pentagon. So what is 900 minus 360? Very nice. So the sum of the interior angles of a pentagon must be 540 degrees. Now it wants you to do the same thing for a quadrilateral. So you're going to draw a picture and do what we just did. Then it says, do it with a decagon. How many sides does a decagon have? 10. Very nice. So you need to draw a 10-sided shape and use this method. And then when you're done, do this reflection. Describe Ryota's method using an n-sided polygon where n represents the number of sides of the polygon. So you're going to write an algebraic formula. Do not Google it. Yes? And then I want you to stop right here before we talk about Joelle's plan. Okay? So I'm going to put you in your breakout rooms to do B, C, and the reflection. Okay? When you're done, come back to this room. Okay? All right. I don't know who you'll be with. You might just be in random rooms. All right, so when you're done, come back here. Just do B, C, and the reflection. Hello, you're all back. Were you done and you just didn't know how to get out of your room? Or were you not done?
We were just working on the reflection.
Okay. All right. Boy, that was a long working on the reflection, let me tell you. So let's talk about it. So when you drew your quadrilateral, first of all, what'd you get for the sum of the interior angles of a quadrilateral?
360.
Yeah. So 360 degrees, which a lot of you probably already knew, right? So you can draw any quadrilateral you want. Doesn't have to be a perfect one, right? Put a dot in the middle, draw your triangles. So you have 1, 2, 3, 4 triangles. So 4 times 180 degrees, which would be what? 720 degrees minus 360 degrees for the circle in the middle. And you would get 360 degrees. Does your paper look something similar to that? Yeah. Okay, good. And then when you did your dodecagon, oh, that was traumatizing drawing, wasn't it? You were like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know if you did that, but that's what I did. 3, 4, 5, 6. All right. Do I have 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't even know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. Okay. Put a dot in the middle. Draw your lines, right? So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles. So 10 times 180 gives you, what does that give you?
1,000. What was it? 1,800.
Yeah. And then we're going to subtract off 360 degrees. And what did you get for a decagon, not a dodecagon?
1,440 degrees.
Is that what everybody got? 1,440 degrees. Okay, so now the hard part. Describe Ryota's method for finding the sum of the measure of the interior angles of any n-sided polygon. Record your method using a general formula where the variable n represents the number of sides of the polygon. Okay, so somebody tell me their reflection. This is the best part.
I can go.
Thanks, Madison.
Of course. So, I said that Ryota says that so first of all, you draw your polygon, right? And we take the number of sides that that polygon has, and then from their general knowledge of knowing that triangles always add up to 180 degrees, you draw your triangles and you multiply the number of sides by 180 degrees, and then you subtract that from the circle. I think that's what you referred it to. And then that will give you the sum of the measures of the interior angle.
Okay, so let's pause a minute. Madison, I love your ideas. I think it's great. Let's just be a little more linear with it. Okay, so number one, draw the polygon that we're interested in finding the interior angles of. What's the next thing in Ryota's method? What's the next thing Ryota does? And this is to everyone in the class.
I said that you put a dot in the middle and
Very
then you
good.
decompose a polygon into triangles.
Very nice. Put a point in the middle. Okay. Then decompose into triangles. Okay. And then what do we do next? This is where we get to Madison's multiplication, right? So we multiply. Now, did you notice that we always had the same number of triangles as we had sides of the polygon? Did you notice that? So if we go back up here, a pentagon had 5 triangles and a pentagon has 5 sides. A quadrilateral has 4 sides and there were 4 triangles. A decagon had 10 sides and has 10 triangles. So we multiply the number of sides, which is the same as the number of triangles, by the way. just in case you want to remind yourself, by 180 degrees. Very nice. Thanks, Sydney, for putting that in the chat. I think it was Sydney. I should look again. Oh, it was, Sydney said it was hard. I appreciate that, drawing the decagon. And Brianna said, multiply by 180 degrees. Okay. And then after we do that, now we're to Madison's next part, which, what did we have to do with all of these? After we multiplied it by the number of sides, what did we subtract?
360. And would those be called the center angles?
We subtracted, yeah, the center angles. The center angles, which was 360 degrees. So if we were going to write a formula for what we just said, what would we write?
I could be wrong, but what I came up with was 180 n minus 360.
Perfect. 180 n minus 360. We kind of said it. We multiply the number of sides by 180, which really sounds like n times 180. But algebraically, when we write notation, we usually put our variable second. So 180 n minus 360. Is everybody okay with that formula? Yeah, this is Ryota's method right here. Now, Joelle uses a different method. Joelle still uses triangles, but instead of putting a dot in the middle and drawing triangles, Joelle chooses one of the vertices and then draws all the diagonals possible. So this is not a diagonal, right? Because it's an edge. So Joelle doesn't draw that one, but Joelle does draw from every other vertice from A. So Joelle chose a vertice and then drew the diagonals of, this is a pentagon as well, because this has 5 sides. So now she has 3 triangles that are all 180 degrees, right? What do you think that tells us? Do we have to subtract anything, or what's happening here? Does this give us the answer that we need? If I know I can decompose this shape into exactly 3 triangles, then I know that if I take the number of triangles, which is 3 in this case, times 180, I get 540 degrees. Now, wait a minute. Isn't that exactly what Ryota got? Yeah. Their method is different. Their answer is the same. Yeah? Okay, so now this is what I want you to do. You're going to use Joelle's method to find the sum of the interior angles of these convex polygons. So for example, pick a vertice. I always like to label it A, so I remember that's what I did. And then draw all the diagonals possible. Well, this is the same shape that we just did because it's a pentagon. So my answer is going to be exactly the same as I just did. So my answer to this pentagon is going to be 540 degrees. But you're going to do it again with this shape and with this shape. After you do that, I want you to write Joelle's strategy and write a formula for Joelle's. It's going to be different than Ryota's. It's not going to be the same. Okay? It's not going to be the same. Okay, so I'm going to give you about 7 minutes in your breakout rooms to do that. When you're done, come back here, or I'm setting my timer for 7 minutes. seconds left. Sarah, were you done?
Yeah, we were.
Michaela, were you done?
Yeah, we're done.
Yay.
Betty, Spike. That I think that's what it was called. Spike.
Yeah, that's kind of how the school was. Yeah,
Okay, there we go.
pretty severe like that.
Anybody else ready for the weekend? Yeah, for sure.
I need to go shopping for a gift for my mom.
For Mother's Day.
Yeah. Do you have any plans for Mother's Day?
My plans are so crazy right now. So my daughter has a choir concert Saturday night. And so my in-laws are going to that. So we have to take them. So that's my mother-in-law's celebration. And then my mom has not decided. She's having a little vaccination issue because she's like, I don't know if I can go to an indoor concert, blah, blah, blah. So if she doesn't come up to the concert, then I will drive down to see her. But then my dad's in it. It's a whole mess, right? It's just a crazy, crazy thing. Yeah. So I have no idea if my kids have anything planned for me, but who knows? Usually they cook me breakfast. So that's very
Oh, that's
nice.
sweet.
Yeah, last year we went on a long run in the morning, and then me and my daughter went on a long run in the morning, and then we came home to breakfast being almost finished. So that was very nice. Yeah, don't forget your moms this weekend, right? Don't forget about it. I know, because we're trying to finish up school and everything. It's a mess of a time. So, okay, let's go over these. So when you did this one, you could have started at any vertice, it doesn't matter, but you made 3 triangles, right? And so if you do, oh, you made 4 triangles. Apparently I can't count when I'm doing this. So 0, 2, 4, 720 degrees. And that was a 1, 2, 3, 4, 5, 6, which is a hexagon. Is that what we figured out a long time ago? Oh, that was our original one. I think we did. Okay, and then this one, same thing. 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5. Boy, I'm having a counting issue all of a sudden. You're like, nope, it's not all of a sudden. Been the whole class. You're fine. 900 degrees for that one. Okay, so who can describe Joelle's method? Madison did a great job last time with Betty's, inserts ideas in there. So who can try Joelle's method?
I can try it.
All right, what's the first thing we do?
The first step is to draw the polygon. And then the second step is to pick a vertice. And after that, we decided to decompose the polygon into triangles by finding the diagonal of the polygon. And then the fourth step is to multiply the number of sides -2 by 180 degrees. And then that just results in the fifth step to find the sum.
Very nice. Number of sides -2 times 180 degrees. All right, now, why are we doing the number of sides -2? Can you figure it out? How come?
Isn't it because the 2 sides that we're leaving out are edges?
Yeah.
And we can't count the edges?
Exact. Right here, these 2, they don't form triangles because they're just an edge of the shape. So we're losing those 2 triangles. So we're going to multiply that. So if we wanted to write this, you could write it 180 times n minus 2. Yeah? Everybody okay with that? Now, these 2 formulas do not look the same. Their strategies are not the same. But are they mathematically equivalent? How do you know? Someone explain to me how 180 times n minus 2, how are they similar or how are they different? So we have Ryota's and we have Joelle's. And the 2 formulas we have is what was our first one? 180n minus 360. And this one is 180 times n minus 2. So how are they similar?
They're both to find the measure of the interior angles.
Okay, finding the same thing. What else?
You're still multiplying the number of sides by 180.
Yeah, we still have 180 in there, right? How are they different? Or you can give me another similarity if you want to.
In Ryotas, you're subtracting 360 degrees.
So you have to subtract that circle, right? And so in Joelle's, we're only using triangles, right? You know, in the other one, we're subtracting circles. Now, in both of them, we use triangles, right? Which is where that 180 came from. Okay, so now, this is your task now. Your task now is to fill in this table. So I think you could do this edges part pretty easy, 3, 4, and so on. The method of choice. I don't want you to just write Joelle or Ryota in here. I want you to show me which formula you're using. So if you want to write Ryota or Joelle, that's fine. But more importantly, I want you to write in the formula you're using, okay? And then show your calculations here. So this one, a triangle is kind of hard, isn't it? Right? Because we have 3 sides, but we can't draw any triangles. There's only one triangle. So this one's a little bit different. So this one is kind of different, right? Because this is just 180 degrees. But on the quadrilateral, you can use whatever you want. You can use 180 n minus 360, which would be 180 times 4 minus 360, which would be 720 minus 360, which would be 360 degrees. And you can show that work all right here if you want. Okay, I don't care. So try that one. Oh, I guess for a triangle, we still could do the other method, right? We could put a dot in here and draw all these triangles, right? We could do that. Just seems a little weird, right? Well, since I already know a triangle, but I could do 180 and minus 360, and I could do 180 times 3 minus 360, which would still give me 180 degrees. Okay, so if you finish that part, you can start doing this one, but I'm going to get you started on this. Now we're going to look at the exterior angles. If this is an equilateral triangle, I know the measure of all these angles. If I'm drawing exterior angles, watch carefully how I do it. You need to extend the lines, but only in one direction. Does that make sense? You don't go both ways, just so you know. And then you can start answering the questions down here. Okay? All right, so fill in the whole table. If you get this far, keep going. Okay, if you need my help, call me in. I'm going to put you in your breakout rooms for about 10 more minutes. Call me in if you need me. Woohoo! Everybody's coming back now. Excellent. Okay, I don't know how far you got, but it's okay. No matter how far you got, it's fine. As long as you understand these two different strategies. By the way, has anyone seen these formulas prior to this? Like prior to this class, either of these formulas? Raise your hand if you have. Tyler, Bethel, Amanda, they seemed familiar, Madison? Yeah. Okay, now, were you taught one of these methods or were you just given the formula?
We like didn't go so much into details of this formula. She just kind of like gave us the formula, what like n represents, the shape, and then told us, okay, let's go ahead and figure it out.
Yeah, how about the rest of you? Were any of you shown like Ryota or Joelle's method with an image? Amanda was excellent. Was that in high school?
Yeah, they gave us the equation and the image at the same time, and then they just kind of asked us to figure out how they got it. So we didn't like find it as much as we did.
Yeah. So I think it's really cool to do it this way. I think it makes so much more sense in my head to, you know, actually know where the formula came from and be able to use it on something. So I really, really like this idea. And it's much easier because now you don't have to even have to memorize a formula because you could figure it out. Okay, so you do not have to finish the rest of it, but you can. It's not an assignment that's due, but I will want you to just kind of think about the exterior angles of a polygon. And on the worksheet, there's a really nice interactive that you can see what happens. And then we'll do the big reveal on Monday about that. Don't forget to do your assignments. There's an exit ticket. There's 2 problems. I'm pretty sure you can do them both. You're going to have to think a little bit, but you can do it. And then I'll publish the new week as soon as I can. And I'll send you a message when it's published, okay? So you can get to work right away. And if you have any questions at all tomorrow or over the weekend about whatever, let me know, okay? Otherwise, happy Thursday. This was fun because you got to work together for so much, right? I mean, maybe you just sat in your room silently and didn't talk to each other, but you could have talked to them. How's that? All right. And it was not as much me talking, more you guys doing work, which I appreciate. Nice. I'm seeing lots of right answers. Good job.